Platinum and palladium can be used as a catalyst in normal temperatures also, but nickel should be used as a catalyst under high temperature. If you are adding a reagent to an unsymmetrical alkene, the negative part of the reagent will get attached to the carbon atom which is having less number of hydrogen. If the hydrogen is getting attached to this particular carbon atom, you will get CH3, CH2, CH2 plus and Br minus. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. Last session, we discussed about the conformations in alkanes, that is eclipsed and staggered conformation, and then the two types with which we can represent it, yes, Neumann's and Sawhorse conformation, right? Yes. Now, nomenclature of alkenes, we started with alkenes, right? So, we completed nomenclature of alkenes and the method of preparations of alkenes as well as the physical properties of alkenes. So, in today's session, we are going to study about the chemical properties of alkenes, that is the chemical reactions of alkenes. So, let's begin with the first one. Alkenes are reactive due to the presence of pi bond. So, already we have discussed this when we studied about the introduction to alkenes. Alkenes contain double bonds, right? They are unsaturated hydrocarbons which contains at least one double bond, right? And due to the presence of this pi bond or pi electrons, they are more reactive than alkanes, right? Electrophiles attach this negative ridge center to form addition reactions. So, alkenes undergo which type of reactions? Addition reactions, because electrophiles will attack this negative rich centers. So, what is electrophile? Electrophiles are those species, right, which have affinity towards electrons or negatively charged particles. So, they themselves will be positively charged, right? So, let's see the first reaction, that is addition of hydrogen. So, to an alkene, that is a double bonded system, if we are adding hydrogen, it becomes a single bonded system. That means if you have a double bond here, I am adding hydrogen to it, this double bond will break and you will get a single bond. That means from alkenes, if we do hydrogenation, hydrogenation means addition of hydrogen, we will get alkanes, right? So, the same procedure happens for alkynes also. To alkynes, if you are adding hydrogen, we will get alkenes. And to alkenes, if you are adding hydrogen, we will get alkanes, right? So, the same reaction you are going to study about alkynes as well. So, let's see here. Alkenes reacts with hydrogen in the presence of nickel, platinum or palladium to give alkanes. And this is called as catalytic hydrogenation. So, you already know what is hydrogenation, addition of hydrogen. And why it is written catalytic? Because it is in the presence of a catalyst. Either it can be nickel, platinum or palladium. So, what you have to remember is platinum and palladium can be used as a catalyst in normal temperatures also. But nickel should be used as a catalyst under high temperature. Okay. So, as you can see here, a common general representation is given here of an alkene RCH double bond CH2. To which you are going to add hydrogen in the presence of nickel at 250 degrees Celsius. If you are using platinum or palladium here, you can just write PT or PD. No need to represent the temperature there. So, what happens here? We are adding hydrogen. So, what happens is this double bond breaks. One hydrogen will be added here, one hydrogen will be added here. Right. So, what happens? You will get RCH2 single bond CH3, right? RCH2 single bond CH3. So, one example we can take of ethene. CH2 double bond CH2, which is an alkene. So, what happens, to which we are adding hydrogen in presence of nickel at 250 degrees Celsius. Again, what happens? One hydrogen added here, one hydrogen added here, right? So, you will get CH3, which is ethane, right? From ethene, you obtained ethane. Now, the next one, CH3 single bond CH double bond CH2, to which hydrogen is added in the presence of catalyst. Again, what happens? In this place of double bond, hydrogen and hydrogen will be added. So, what you will get? CH3, CH2, single bond CH3. That is from propene, you obtain propane. Right? So, I hope this is clear. So, this is the catalytic hydrogenation, that is addition of hydrogen in presence of catalyst. Now, moving on to the next one, that is addition of halogen. Okay, so what we are going to add here? Halogen. So, you can also call this reaction as halogenation, right? Addition of halogen. So, halogens, normally we use chlorine or bromine. Reacts with alkenes in the presence of inert solvents like CCl4, carbon tetrachloride, to form dihaloalkanes. So, you're going to get alkanes, Okay, because we are adding something. So what happens to the double bond? It will become single bond. So you're going to get alkanes. And what are we adding here? Halogens. So you will get dihalogens here. That means 2 halogen atoms will be added here. So as you can see here again, RCH double bond CH2, to which bromine is added. Right? Bromine is added in presence of inert solvents like CCl4, carbon tetrachloride. Okay, so what happens across this double bond? One bromine atom will be attached here, one bromine atom will be added here. That's it. So you will get a dihaloalkane. So when you are adding something here, what happens to the double bond? It will become a single bond, right? So you will get RCH, single bond Br, single bond CH2 Br. No other changes happen here, just the bromine will be added, the double bond will become single bond, right? Let's take an example of ethene again, okay, to which we are adding bromine molecule in presence of CCl4. So what happens? Yes, this double bond will break. One bromine added here, one bromine added here. So you'll get CH2Br, CH2Br. Now what is the name of this? It is 1,2 dibromoethane, right? This main chain is ethane, to which 2 bromine atoms are added. So it's on the first carbon and second carbon. So 1,2 dibromoethane, right? Now the next one, propane, to which we are adding one molecule of bromine in presence of CCl4. One bromine added here, one bromine added here. And what will happen? The double bond will become single bond. So what you are getting? CH3, CHBr, CH2, Br. So what will be the name of this? It is 1, 2, 3. This is how you number it, right? It's the branch which we have to consider. So what you are going to get? 1,2 dibromo, but it is propane, right? 1,2 dibromopropane. So this is addition of halogen. Now moving on to next one, addition of hydrogen halide. This is a very important reaction, addition of hydrogen halide. So when alkenes reacts with hydrogen halides, they form alkyl halides. So you already know what is alkyl halide. General representation can be Rx. For example, let's take CH3Cl. This is called as an alkyl halide. Why? There is an alkyl group as well as an halogen. So this is alkyl halide. So what we are going to do here? Addition of hydrogen halide. So hydrogen halide means what? We can represent it as HX. That means it can be HCl, HI, HBr, etc. Right? Okay, so we are going to add hydrogen halide and we are going to get alkyl halide. But this reaction is important because this reaction occurs or it follows a very important rule which is called as Markovnikov's rule. According to this rule, this reaction will take place. Now, why this rule is important? Because in this case of addition of halogens as well as addition of hydrogen, both the atoms were same. It was H2 here, it was Br2 or Cl2 here. But in this case, we are going to add hydrogen halide. That means H and X. There is an electronegativity difference there, right? So, if you are taking HCl, for example, what happens? Chlorine is more electronegative. There is an electronegativity difference here. So, based on that, what we are going to study is the Markovnikov rule, which is very important. So, let's understand first what is Markovnikov rule and then we'll go to the reaction. So, it states that when an unsymmetrical reagent adds to the unsymmetrical alkene. So, it is an unsymmetrical reagent, right? HX. It is unsymmetrical. Both the atoms are different. And when it is added to an unsymmetrical alkene, if it is a symmetrical alkene, you can add it on either of the atoms, which I'll explain now. But if it is an unsymmetrical alkene, you have to use this rule. So, then the negative part of the reagent adds to the carbon which contains less number of hydrogen atom. Okay, so that means if you are adding a reagent to an unsymmetrical alkene, the negative part of the reagent will get attached to the carbon atom which is having less number of hydrogen. So let's now come back to the reaction here. It is RCH double bond CH2 to which we are adding HX, hydrogen halide. So in hydrogen halide, hydrogen will be the positive charge. Okay, and the halogen will have the partial negative charge. Why is this? Because halogen are more electronegative than hydrogen. So what happens? This is your reagent. So what does the rule say? The negative part of the reagent will get attached to the carbon having lesser number of hydrogen atoms. So as you can see, the double bond is present here. Right? The carbon atoms involved is this and this one. So out of this, which carbon atom is having lesser number of hydrogen? This carbon atom. Right? So that is clear. So what happens? The negative part of the addendum or the reagent will get attached to the carbon having lesser number of hydrogen atom. So your X will get attached here. Now if X is getting attached here, see, if the X is getting attached here, what will happen to the hydrogen? Hydrogen will get attached to the adjacent carbon atom. So hydrogen will get attached here. So what will be your product? RCHX, and the hydrogen will be attached here. So you will get CH3. Understood? So that is the rule. So let's take the example of a symmetrical alkene here. CH2 double bond CH2. It is ethene. So in this case, is there any confusion? No, because either you can add the H here or Br here, because it is a symmetrical alkene. If it is unsymmetrical, what you have to remember, the negative part of the reagent, that is your halogen part, should be attached to the carbon having lesser number of hydrogen atoms. Okay, so I hope that is clear. One more example, let's take of propene. CH3 CH double bond CH2, to which we are adding HBr. So what happens? H is partial positive, bromine is negative one, right? So what happens? The bromine will get attached to the carbon atom having lesser number of hydrogen atoms, which is this one, right? So you'll get CH3 CHBr, and the CH2 will become CH3. The hydrogen will get attached here. Okay, so I hope the rule and the reaction is clear for you, right? So now let's understand the mechanism of this particular reaction, that is addition of hydrogen halide. So the reaction takes place in 3 steps. The first step is hydrogen bromide dissociates to give H plus and Br minus. So we are going to take the particular example of HBr, hydrogen bromide. So what happens here? HBr, as I told you, bromine is more electronegative. So what happens? Bromine will get partial negative charge and hydrogen will have partial positive charge. So it will dissociate into H plus ion and Br minus ion. So that is the first step. Now step 2, the electrophile H plus. Which is the electrophile here? H plus, right? Electrophile means which is having attraction towards negative charge. So it must be positively charged, right? So H plus is the electrophile here, attacks propene to form a carbocation, carbon having positive charge. So as you can see here, this is the propene. We have taken example of propene. Right, so CH3 CH double bond CH2, propene we have taken here, to which we are adding our HBr. Okay, so what happens here? The H plus is going to attack here. Electrophilic attack is going to happen here. So either the H can attack here or the H can attack here. Okay, so based on that you will get 2 different products. So first case, if the hydrogen is getting attached to this particular carbon atom, you will get CH3, CH2, CH2 plus and Br minus. Right, so what happens? This Br is Br minus, right? If I am considering the first product, hydrogen is getting attached to this carbon atom. So what will happen? The hydrogen is getting attached here, but the adjacent carbon atom will get the positive charge, right? So this will be the first product. Now another possibility is that the hydrogen can get attached to this carbon atom. So what will you get? CH3, CH, CH3. Right, and the carbon, this carbon will get the positive charge because the hydrogen is getting attached in this carbon atom, and there will be Br minus. Okay, so as you can see here, now you got 2 different carbocations. Now you have already studied this in organic chemistry, the order of stability of carbocation. If you have a primary, secondary and tertiary carbocation, yes, tertiary carbocation will have the highest stability, then secondary, then primary. So this you have already studied in organic chemistry chapter. So this is the order. So as you can see here, there are 2 possible products. One is this one. Yes, as you can see, this is a primary carbocation, and in this case you can identify this is a secondary carbocation. So comparing these 2, which will be formed or which will be the major product? Yes, it will be this. This will be the preferred product because it is a secondary carbocation and it is more stable. Okay, so I hope that is clear. Of the 2 carbocations, secondary carbocation, which is B, is more stable than the primary carbocation. Hence, only B will be formed. So out of these 2, why we are preferring this one? Because it is more stable. It is a secondary carbocation, right? So we are going to actually, what we are studying here is why it is actually Markovnikov rule that we are following here. Okay, see, I told you the negative part of the reagent will get attached to the carbon atom having lesser number of hydrogen atom. But why this is happening? Why? What is the mechanism behind this we are studying? Okay, so I hope the second step is clear for you. Out of these 2, the secondary carbocation is more stable. Now moving on to the third one, the nucleophile Br minus is also there, right? The nucleophile Br minus attacks the carbocation to form 2-bromopropane. Okay, so now what happens? Yes, the Br minus is there, which is the nucleophile here. Now it will go and attack the B, which is the B here. We already discussed that is a secondary carbocation. So what happens? The Br minus will get attacked here and you will get CH3, CHBr, CH3. Okay, so why this Markovnikov rule is applicable here is because the secondary carbocation is more stable. So hence what happens to this, the negative charge and positive charge, now the carbon got its valency, right? No problem. So this is the final product you are going to get here. Okay, so that is Markovnikov rule and the mechanism of addition of HBr. Now there is one more rule that you have to study, which is called as the anti-Markovnikov rule. So let's see, addition of hydrogen bromide. Specifically we are going to talk about hydrogen bromide here to propene in the presence of peroxide. Now if this reaction, the same thing, if you are adding hydrogen bromide, okay, in the presence of peroxide, that is important, in the presence of peroxide, catalyst takes place against Markovnikov rule. Okay, so if there is presence of peroxide, the reaction will happen in the opposite way. What that means is that is anti-Markovnikov rule. So what does that mean? Just now we studied according to Markovnikov rule, the negative part will get attached to the carbon having less number of hydrogen atom. But if there is presence of peroxide catalyst, what happens is the exact opposite will happen. That means the negative part of the reagent will get attached to the carbon having more number of hydrogen atoms. So let's see here, CH3, CH double bond CH2, and we are going to add HBr here. So according to Markovnikov rule, what happens? Hydrogen should get, that is bromine, which is the negative part, should get attached here. That is what we have studied now. But as you can see, there is presence of peroxide here. So what happens? It will follow anti-Markovnikov rule and the negative part will be attached to the carbon having more number of hydrogen atom. So this is the product you are going to get, CH3, CH2, CH2Br. Okay, so instead of attacking here, it will attach to this carbon atom having more number of hydrogen atom. Okay, so it is called as anti-Markovnikov rule or peroxide effect or Karash effect. Okay, so I hope Markovnikov and anti-Markovnikov rule is clear for you. Now, let's understand the mechanism for peroxide effect or the anti-Markovnikov rule. So, peroxide effects proceeds via free radical chain mechanism. Okay, in the case of Markovnikov rule, we studied there is a formation of carbocation to which the nucleophile will attach. So, in this case, what it is having, it's a free radical chain mechanism. So, let's understand, this is benzoyl peroxide which is taken here, C6H5, C double bond O and C double bond O, C6H5. So, now what happens is homolysis take place. So, even this you have studied in organic chemistry. When homolysis take place, free radicals are formed, right? So, what happens? This will break. Homolysis, what will happen? You will get two molecules of C6H5, C double bond O and O. Okay, so you are going to obtain this. Now, to which what happens? The carbon dioxide will be removed, and what will be that you are going to obtain? Two molecules of C6H5 radical and carbon dioxide will be removed. Right. So now to the C6H5, if we are adding the radical, we are adding HBr. Again, homolysis take place, and you will get C6H6. Right, this hydrogen will get attached here. Now what will happen to bromine? Bromine will get the free radical. Okay, so this is the first step, you got the bromine free radical. Now what happens is, this bromine free radical is going to attach to the propene. So we are taking the example of propene here. So now here also there are two possibilities, right? The bromine get attached to this carbon atom or else this carbon atom. So based on that, you will get two different products, right? So what happens if bromine is getting attached to this carbon atom? So what will get? CH3, CHBr is attached here and the free radical will be to this carbon atom. So you will get in this form. Right. Now, if the bromine is getting attached to this particular carbon atom, what will happen? CH3CH, CH2Br you will get, and this carbon will get the free radical. So, these are the two products you can see. Again, we have to compare like what we have done in Markovnikov rule. Now, out of these two, which is more stable? Yes, even free radical order of stability we have studied. It is again tertiary, secondary, primary. It's the same as that of carbocation. So, tertiary free radical is more stable, then secondary, then primary. So, as you can see here, this is an example of a primary free radical and this is an example of a secondary free radical. So, comparing these two, this will be more stable and this will be the product which is formed. Okay, so out of these two, the secondary free radical will be formed. Okay, now what happens is that we understood, okay, this is the product which will be formed. Now to this secondary free radical, HBr is added. The hydrogen will come and attack here. So you will get CH3, CH2, CH2Br and Br minus, right? This Br minus will be still there. So that is the Br minus, which will be the major product. And you will have the minor product also when the hydrogen is attacking here. So that is what you are getting here. CH3, CHBr, CH3 and Br minus will be released. So this is the minor product. So since secondary free radical is formed in the step 3 is more stable, 1 bromopropane will be the major product. Hence, this will be the major product. Right. So that means that this is the less stable one and this is the more stable one. So this will be your major product. That is, bromine will get attacked here. That will be your major product, and bromine getting attached here, that will be the minor product. So I hope anti-Markovnikov rule is also clear for you. Moving on to the next one, that is addition of sulfuric acid. So addition of sulfuric acid also follows Markovnikov rule. So you know what is sulfuric acid? H2SO4. Now in this H2SO4, again according to Markovnikov rule means you should be knowing the negative part will get attached to the carbon having lesser number of hydrogen atom. So that means in H2SO4, H plus is the positively charged cation and OSO3H, that is HSO4 minus. Okay, you can also write it as HSO4 minus. So that is HSO4 minus, which will be the negative part of the reagent. So now it follows the same as that rule of Markovnikov rule. Cold concentrated sulfuric acid adds to alkene in accordance with Markovnikov rule to form alkyl hydrogen sulfate by electrophilic addition reaction. So let's see here, RCH double bond CH2, to which you are adding H2SO4. So what happens? The negative part, as I told you, it is OSO3H, which is the negative part. So negative part will get attached to which carbon atom? Which is having lesser number of hydrogen atoms. So it will get attached here. So you will get OSO3H here, and which is the positive part? It is hydrogen, which will get attached to the adjacent carbon atom. So you will get CH3 here. That's it. Clear? Now let's take CH3, CH double bond CH2, which is propene, to which we are adding H2SO4. So what happens again? It is H plus and OSO3H minus. So what will happen? This SO3H minus will get attached to the carbon having lesser number of hydrogen atoms. So this is the product you are going to obtain. Okay, yes. Now the next one is addition of water in the presence of few drops of concentrated sulfuric acid. So this happens in the presence of few drops of concentrated sulfuric acid. Alkenes reacts with water to form alcohols in accordance with Markovnikov rule. Here also it is in accordance with Markovnikov rule. Okay, and it happens in presence of few drops of sulfuric acid. So again, H2O, it dissociates into, or it contains H plus and OH minus ions. Again, yes, it is according to Markovnikov rule. OH minus, which is the negative part, will get attached to carbon having lesser number of hydrogen atoms. So let's take the example here, CH3C, and you have a branch here, CH3 double bond CH2, to which you are adding H2O. So what happens? H2, as I told you, H plus and OH minus. Now the OH minus will get attached to the carbon having lesser number of hydrogen atom. So as you can see here, here is the double bond. So comparing this carbon and this carbon, which will have a lesser number of hydrogen atoms, this one. So OH minus will get attached here. So you'll get CH3, right? You have one CH3 here, two CH3 here. Now this OH will get attached to this carbon and this will become CH3. So what is your product? You have already one CH3 here, one CH3 here. OH will get attached here and one more CH3. So this will be your product. Okay. Yes. So once you're clear with Markovnikov rule, all these reactions are quite easy. Now moving on to the next one, that is oxidation. Now alkenes on reaction with cold dilute aqueous solution of potassium permanganate. Potassium permanganate is KMNO4. Okay. So alkenes on reaction with cold dilute aqueous solution of potassium permanganate. So the name for this particular reagent is Bayer's reagent. So it is important to know what is Bayer's reagent. You can get it for 1 mark as well. What is Bayer's reagent? So you should be knowing it is cold dilute aqueous solution of potassium permanganate, which produce vicinal glycols, and decolorization of KMNO4 solution is used as a test for unsaturation. Even that is important. So what is that product you are going to get here? Vicinal glycols. Okay, so I've already taught you what is vicinal and geminal, right? So vicinal means you'll get the any reagent that you are adding on adjacent carbon atoms. So as you can see here, one OH in this carbon atom, one OH in this carbon atom. On adjacent carbon atoms, you will get the reagent. So that means that is vicinal glycols. Okay, and one more important point is decolorization of KMNO4 solution. Okay, so what happens to the color? KMNO4 solution is having a purple color. What happens is once this reaction happens, the color of the KMNO4 will be discolored. So what happens? This is used as a test for unsaturation. That means to identify whether your reactant or the compound or the hydrocarbon which you have taken is having double bond or triple bond, you can use this test, right? So let's see. We have taken ethene here, to which we have adding water in presence of dilute KMNO4, 273 Kelvin. What is this water present here? It is given cold dilute aqueous solution, right? So what happens? It's simple. OH will get attached here, one OH will get attached here. That's it. So you will get a vicinal glycol. Now the another method of oxidation is acidified potassium permanganate or acidified potassium dichromate. Potassium dichromate is K2Cr2O7. Okay, oxidizes alkenes to ketones or acids depending upon the nature of the alkene and the experimental conditions. Okay, so the first one, if you are using Bayer's reagent, you will get vicinal glycols. Now if you are taking acidified KMNO4, this was dilute KMNO4. If you are taking acidified KMNO4 or potassium dichromate, so what you are going to get? You will get ketones or acids based on the nature of the alkene as well as the experimental condition. So let's take the example of propane here, CH3, CH double bond CH2, to which you are adding oxygen. It's oxidation, right? So that is what is represented here in presence of acidified KMNO4. So you have to find out the difference between this and this. This is dilute KMNO4 in presence of water, right? It is aqueous. This is acidified. So what you are going to get? You will get ethanoic acid, CH3COOH. It's ethanoic acid, water and carbon dioxide, right? Now if you are taking another alkene, which is butene, right, or but-1-ene, 1, 2, 3, 4 carbon atoms are there. So what happens? You will get CH3CH2COOH. Okay, that is you will get propanoic acid, water and carbon dioxide. Now if you are using but-2-ene and adding oxygen, that is oxidation in presence of acidified KMNO4, you will get 2 molecules of ethanoic acid. What happens? One OO will be added here, 2 molecules of oxygen will be added here. So you will get CH3COOH and CH3COOH, 2 molecules of this. So I hope this is also clear. So now moving on to the next reaction, that is ozonolysis. Okay, so ozonolysis, from the name itself you can identify it's something related to ozone, right? So what is ozone? It is O3, right? So let's see. Ozone adds to alkenes to form an ozonoid. So first you will get an intermediate stage which is called as ozonoid, which is hydrolyzed with zinc and water to give aldehydes or ketones. So this reaction is called as ozonolysis. So let's take an example. So you have propane to which we are adding ozone. So what happens here? As you can see, the double bond is here, to which the 3 atoms of oxygen will be added. So as you can see, CH3 will be sealed here, and to this double bond, the 3 atoms of oxygen will be added. So as you can see here, CH here, CH2 here. That will remain the same. You'll get 1 oxygen here, 1 oxygen here, 1 oxygen here. Okay. Now what happens is, yes, this is the first intermediate that is formed, which is the ozonide. Okay, now from ozonide what happens, when we hydrolyze it in presence of zinc and water, what will happen is this bond will break in this manner. So what is that you are going to get? CH3CHO, right? In this part you will get CH3CHO, and what you are having here, CH2O, that means HCHO, it is an aldehyde, right? So CH3CHO, aldehyde, again HCHO, it is another aldehyde, and this oxygen will combine with the zinc that we are using for hydrolyzing. Okay, so you will get ethanol and methanol here. So let's take one more example, CH3 and double bond CH2. So as you can see the double bond here, to which the 3 atoms of oxygen will be added, and you will get the ozonide. Okay, so as you can see this part will still remain the same, and across this double bond the 3 atoms of oxygen will be added, 1, 2 and 3. Now what happens, as we have done in the same in the previous example, this part will be broken. Now what will happen in presence of zinc? Okay, so what happens? You will get CH3, C, CH3 and this O is there. That means what? You are going to get a ketone, right? So CH3, C double bond O, CH3, that is ketone, okay, which is propane 2-on. Now what is present here? It's the same as that we got here, CH2O, that is HCHO, that is methanol. So this is how you can write the mechanism, or you can see the reaction in this form. Okay, so this is ozonolysis. Now the last one is polymerization. Okay, it is called as polymerization. When alkenes are heated under pressure in the presence of suitable catalyst, they undergo polymerization to produce polymers. So polymerization means what? Production of polymers. So the simple compounds from which polymers are made are called as monomers. So a number of monomers will combine together and form polymers. For example, we are taking ethene here, which is heated as 200 degrees Celsius under 1500 atm pressure. So under high pressure and temperature, in the presence of oxygen catalyst, polyethylene is obtained. So what you can see here, ethene is taken. Okay, N molecules of ethene is taken. Yes, under high temperature and pressure in the presence of catalyst, you obtain polyethylene. As you can see here, it is written CH2CH2 and N times. That means this is a monomer which repeats N times, you will get a polymer. As you can see here, another example, CH3, CH double bond, CH2, that is propene, which forms polypropene. So this is repeated N times. This is a monomer which is repeated N times, you will get the polymer. Okay, so this is polymerization under high temperature and pressure, and in the presence of a catalyst, you will obtain the corresponding polymer. So I hope the chemical reactions of alkenes is clear for you. So in the next session, we are going to start with alkynes, the physical properties, chemical properties, nomenclature, methods of preparation, all of that we are going to do for alkanes as well. So I hope the concepts that we have discussed in this session is clear for you. So that's all for today. Thank you.